Howdy, howdy. Let's see what's going on here. So today I'm going to talk to you a little bit about two of the MyAP quizzes. It is kinetic and static friction and Newton's third law quizzes. So let's start off with kinetic and static friction. First of all, the the idea of falling objects and why all falling objects fall at the same rate has to do with the net force over the mass is acceleration. And when we're falling, the force is simply, when we're free falling, the force is simply acceleration is mg over m. And so if it's an m or twice the m, it doesn't matter because the m cancels to give you a equals g. And if it's 2m, then the 2m cancels and you get a equals g. And so they have the same acceleration. In this case, same acceleration. Now, what if you have the coefficient of friction and something is slowing down? You still have the net force is the acceleration. So the net force in this case is slowing them down, and the mu sub k is a constant for the surface, the types of surfaces that are sliding against each other. So as long as the types of surfaces are sliding against each other are the same, the coefficient of friction is the same. Now we still have the same equation. Acceleration equals net force divided by mass, but in this case the net force that's slowing them down is the force of friction. The force of friction is defined as mu sub k times Fn, and since Fn is basically on flat ground, at least, is directly related to the weight, which has mass, then you have this equation, which leads to this equation. So u sub k equals mg over m, and you can see what happens. The m cancels, and so if you do the 2m one, exact same equation, a equals mu sub k times 2m times g divided by 2m, and once again they cancel, and so they will actually slow down at the same rate, which is kind of interesting. The As long as you don't change the weight of a car, the size and the shape of the tire has the same amount of friction. Friction is determined by the equation mu sub k times Fn. That's how you get friction. And so just remember that when you're talking about these things. It's pretty simple to think of, is that the friction is mu sub k times the force that's pressing the surface together, which on flat surface is directly related to Fn. Anyways, there's a lot of questions on how to find friction, so you got to know the difference between static friction and kinetic friction. Kinetic friction obviously can be accelerating or can be going at dynamic equilibrium, whereas static friction has to be stationary. It's not moving. So just keep that in mind and try to do some of the math and the drawings and the equations for those. Let's move on to Newton's third law quiz. And so Newton's third law says that for every force, there's an equal but opposite force, and additionally, forces always come in pairs. And so let me show you some example comparing Newton's third law to Newton's second law. So it says here, Newton's second law refers to one object, while Newton's third law always refers to two objects. So if you look here on the left, this is a wall with a spring, and the spring has given a force to the mass, causing it to accelerate. The second object, actually, if you're going to think about Newton's third law, the second object would actually be the wall. And in this case, see if I get a little bit more out of my view there. In this case, the wall isn't really needed to solve it. So for Newton's second law, we're only going to think about the force on this mass and acceleration of this mass. Okay? So in Newton's third law, you got to remember that you're always talking about an interactive force pairing where there's two masses. And so the force, like for instance, if you go back to this, the force of the spring, which is the S, is not necessarily the same as the force of the kinetic friction, right? So that's not a force pair. Even if you like drew them opposite directions, that would not be a force pair because it's on the same mass. But over here, the force pair is the interaction. The force of the spring on this mass is the same as the force of the spring on this mass. So the forces between them are the same, but since there's two objects, this one has a smaller mass, it will accelerate more. and this one has a larger mass, it will accelerate less. So this says 2 times the mass, 1/2 the acceleration. This says 1/2 the mass and twice the acceleration. And that's how Newton's third law works. Whenever you see these things, it doesn't really matter if a cup presses against the table, then the table presses against the cup with the same amount of force. That's two separate objects. If a bat hits a ball, then the ball hits the bat with the same exact force in the opposite direction. Those are Newton interacting force pairs. And there's a lot of questions concerning those things on this quiz. Some of them are just as easy as saying, "Oh, yes, they are Newton interacting force pairs, so they have to be equal," as opposed to like overthinking it, right? So that's what that's supposed to help you with. And then finally, when you get into Newton's third law, and we'll talk about this in class with respect to stuff like trains, like in today's we'll talk about the force of tension between these two different trains. When you look at those, very often they talk about an ideal spring, and I did mention this in class the other day. An ideal string is a string which is massless, and so the force of tension is transferred directly through the string with no change in tension. Although that's not always true. If you have a heavy rope or if you have a heavy chain with links, there's a different force of tension depending on where you are in the link, especially when it's vertical. And I gave you the example of the slinky, right? So where can you see that? You can maybe see that right there, right? The slinky is farther apart. Right there? No. Farther, right there is farther. So I say farther apart toward the bottom. You can't really see it, can you? And closer together toward the top. And that's just the demonstration showing you there's a differential amount of tension on different locations. So just keep that in mind as you go through and see if you can kind of reason through those. Anyways, that's actually 2 quizzes. Make sure you like kind of record somewhere in your notes or take a screenshot of the questions that you're struggling with, because not a lot of people are asking me questions. They're like, "Oh, hey, that's a hard quiz," but yet not asking me any specific questions. So hard for me to answer that if you don't give me some direct feedback on that. So give it a try and let me know what you think.